Have you ever wished you could make things simpler? I mean, I think everybody has, oftentimes in math. And I don't know that anybody could have wanted things to be more simple than Donald Duck.
Pi is equal to 3.141592653589747, etc., etc., etc.
Now, there's three different ways you can express this concept, right? There's pi, the Greek letter pi itself. You can represent it as a regular number as a decimal, right? 3.14159, etc., etc., as the little shapes said. Or you could express it as a fraction, 22/7. Sometimes it's just easier to express something in a different way so that you can handle it and make use of it. Now, in this video, we're going to be talking about relationships of equivalence, which is different from what we have been talking about, which is relationships of opposition. So let's take a moment, do some review, and get some definitions. So here's our friendly kangaroo, and she says, relationships of opposition examine propositions that are implied by other propositions. And you're going to want to write that down. You've probably already got that in your notes somewhere. But again, this is good review. And then our folks start thinking about that. The fellow in blue says, if some kangaroos are animals that remind us of logical terms, are all kangaroos animals that remind us of logical terms? And the fellow in green says, not necessarily. By super implication, the A proposition could be either true or false, since the I proposition is true. All right, those are the relationships of opposition that we have seen on the square of opposition. And of course, Logic Dragon is thinking, let's talk about dragons instead of kangaroos for a change. And then our little kangaroo comes back and she says, relationships of equivalence, on the other hand, help us understand which propositions are the same by removing confusing language. That's what we're going to be talking about in this video, relationships of equivalence. Logic Dragon pops back up and says, what the kangaroo didn't tell you was that relationships of equivalence can also be called immediate inference, since they immediately tell you which propositions are identical. Now, we've got several different relationships of equivalence, but the one we're going to start working with in this video is obversion. Obversion applies to all four categorical propositions, A, E, I, and O. All right, we can have a relationship of obversion for each of those four propositions. To obvert a proposition, you must do two things. First of all, you have to change the quality of the subject from affirmative to negative or negative to affirmative. Remember, quality is what talks about affirmative or negative. Okay, so you got to change the quality of the subject. And then the second thing to do is to change the quality of the predicate to its complement. And that's something a little bit different, so let's talk about what that actually means. So once again, here's a little chart for us. All right, so we've got our categorical propositions in the left-hand column, and then we have their obversion in the right. So if the A proposition is all S is P, the obversion would be no S is non-P. All right, so we've changed all, we changed the positive, the affirmative, to no, and then the predicate, instead of P, we're saying non-P. And this might even be worth jotting down as well. To make something the complement, just put in the word non, N-O-N, non, all right? To just take another example and we'll see what I mean. No S is P, that's the E proposition. Okay, so again, we're keeping it universal, but we're flipping it over to affirmative now, and we say all S is non-P. All right, non-P is the complement, we say, of P. I, some S is P, becomes some S is not non-P. I know that sounds really, really strange, but notice we've changed from positive to negative, from is to is not. Then we've changed P to its complement, which is non-P. And then finally we have O, some S is not P. Or some S is not P. And so we change that to some S is non-P. All right, we've changed the negative is not to the affirmative is. And again, we've given the complement of P, which is non-P. Now I think we're going to need some help understanding that, and so do our little friends. Logic Dragon comes up and says, since you like games so much, let's play the logic game. And so he puts up a statement, all dogs are canines, and says, what is the obversion of this proposition? And the girl in gold says, I've got it. No dogs are non-canines. Right? She's changed it from a affirmative to a negative, and then she's changed canines to non-canines. Logic Dragon says, great, now what about this one? No homeschool students are public school students. And the fellow in green says, I know, all homeschool students are non-public school students. And again, he's changed the quality of the subject from negative to affirmative and changed the predicate from public school students to its complement, non-public school students. Logic Dragon says, wow, keep going. The next phrase that pops up on the screen, some ice cream is chocolate. And the fellow dressed in black says, over here, some ice cream is not non-chocolate. Again, we've changed the quality from positive, is, to is not, and we've changed the predicate from chocolate to its complement, non-chocolate. And then Logic Dragon says, awesome. Now, what about this last one? And the new phrase comes up on the screen, some pizza is not deep dish. The fellow in blue says, I've got this one. Some pizza is non-deep dish. And once again, he's performed the obversion. Right? He's changed the negative quality is not to is, and he's changed the predicate deep dish to the complement non-deep dish. Now, there are a couple of language issues we need to delve into when talking about obversion. One is double negatives, and the other one is using an opposite as a complement. And we're going to see what's going on with those things in the next couple of examples. So our little kangaroo comes back up and says, what if someone said, no non-professional athletes are not hoping to go pro someday? And the blue kangaroo says, well, that sounds a bit confusing, and we can simplify it through obversion. All non-professionals are not hoping to go pro someday. And the green little kangaroo says, wait, that sounds even worse than before. But then the yellow kangaroo says, yes, but if you remember that two negatives can make a positive, you can remove that double negative, so your statement becomes, all non-professionals are hoping to go pro someday. And Logic Dragon says, or is thinking, now that does sound better. And you may want to go back over that one. Just actually replay this clip of the video to see what's going on there. The obversion may have made it seem a little bit more complicated, but then when you realize the double negatives make the positive, that actually really does simplify things. And then we have to talk about what happens when you use an opposite as a complement. For example, we have the statement, no doctors are stupid. All right, by obversion, that becomes, all doctors are non-stupid. Now, that may sound odd, but you say, well, maybe we can just say something like this. All doctors are genius. Now, you have to be careful with something like that. You may think that genius is the opposite, and so we could use that as the complement to non-stupid. That's not actually the case. You could have a doctor who is non-stupid, right, but not necessarily a genius, right, not necessarily operating at Einstein level, right. You could have a perfectly smart doctor, but still not be genius. So you have to be careful about using the opposite as a compliment. It's sometimes better just to stick with the word non in the predicate. Now, I have to say, ultimately it is about simplifying things, and when the kangaroo did that example about the non-professionals and not seeking to go pro or whatever, to be honest, there are some people who like to talk like that. They like just to almost to brag and to make themselves sound, I gotta be honest, smarter maybe than they actually are by using convoluted, confusing language, and I don't like that. I want things to be simple. In that regard, I'm a lot like King Henry in this clip from a wonderful movie based on a wonderful play, A Man for All Seasons. In this scene, King Henry has come to visit the Lord Chancellor of England, a man named Thomas More. He's come to visit Thomas More at his home, and all of the king's lords have already gone into the house, and the king and Thomas More are talking outside. And the king is getting very, very upset because of the way some people are reacting to him. I want you to watch this clip, and this is how I really think.
What is it? Thought, because I'm simple and plain and deal with every man straightforwardly. Because of that I say, do they take me for a simpleton?
So, it doesn't make you a simpleton or a foolish person to want to make things more simple. And ultimately, that's what the relationships of relevance are all about.